So cross-chain security really depends on two things. The quality and the security of the software that's processing the transactions, and then also the decentralization of the node infrastructure that's processing and managing the risk of those transactions. So there are really 5 levels of security to think about here. At the first level, anyone can make a single server and call it a bridge or call it a data service or something, but it's really just a single server. Some people do this when they make oracles, when they make cross-chain systems. They basically make some kind of bridge, they make a bridge website, they make a server, they control a single server, and they call it a blockchain service. It's not decentralized in any way, it's one server controlled by one key holder, and it's not really creating any additional security or reliability or decentralization. Sometimes these people get contacted and get asked, oh, what is this? Is it decentralized? Is it a real blockchain service? Then the thesis is, oh, that's a problem. Let's make it 2 servers. So then there are certain systems that basically are made up of 2 or 3 servers, sometimes more, but those servers are also controlled basically by one key holder. There's been recent chain hacks where there was a bridge with large amount of chains that it was integrated with, and it all went down because one person had all the keys in their personal laptop, had one key in their personal laptop. So these type of systems where there's one key holder controlling more than one server, sometimes 2 servers, sometimes 3 servers, sometimes more, is not really particularly more decentralized. You have more servers, but those servers are not separated from each other by the key holder or by the software or by anything really meaningful. So that's the second level. Chainlink is never been at either of those levels. At the third level, you have a single network made up of multiple independent nodes. Now this is better than the first 2 levels because now you have multiple independent nodes that are able to process transactions that are separate from each other with separate private key holders. So that's an improvement. The problem with this is that there's no way that this can scale, similarly to how blockchains don't scale. So if you could have a single global ledger for all the world's transactions or all of a type of transaction, then you would have single blockchain worlds, right? You would have a single blockchain that everything ran on. But you can't pass all the transactions that you want through a single blockchain, and likewise you can't pass all your transactions through a single network of a single set of nodes. And the problem here will be that you basically have spikes in usage from certain pairs or certain bridges that are in this one shared network, and that sharing of the network will slow down all the other bridges until you get to a point where the whole thing just breaks and it just can't process transactions, especially if 1 or 2 of those bridges simultaneously become very rapidly used at scale. And so the reason that most people make that third one is because their system doesn't know and isn't made to generate multiple networks. The Chainlink network from the beginning was about making multiple decentralized oracle networks. It was never about creating a single network through which all transactions of any kind of data or cross-chain or compute or anything would be passed through. The whole point of the Chainlink framework is to generate multiple oracle networks. So this is where you get to level 4. And Chainlink has been at level 4 for many years. Basically the ability to generate multiple separate networks dedicated to performing their specific function. So the way that you could view Chainlink networks is like services, decentralized services. There are many Chainlink Oracle networks that are on production securing value as decentralized services for transmitting data after validating it and making it reliable and immune to certain types of manipulation. And that is really where Chainlink started, is how do you create multiple individual Oracle networks for validating data. Now Chainlink has moved on to not only validating market data and proof of reserves and identity and various other types of data, but also using those Oracle networks to do computations and now cross-chain. So Chainlink fundamentally is not about making a single network or a single chain. There is no Chainlink chain. It is about making multiple separate decentralized services so that you can have the security of each service segregated to that Oracle network, and so that you can scale that Oracle network to the maximum degree possible as you want to scale that service. And Chainlink has been at this level for many years now, and in the Chainlink network there have been well over 1,000 Oracle networks launched into production securing real value. If you count the testnet networks, the staging networks, all the other networks that didn't secure value, it's in the thousands. At the fifth level, which only Chainlink resides at this level from the point of view of making secure systems, and really only on an Oracle network basis, only Chainlink really resides at the fourth level, you have the ability to both make multiple networks and the ability to manage risk. So the ability to manage risk depends on detecting various risky events, categorizing them as risky, and then enabling the system to adapt to remove those risks. For example, on the data side, the Chainlink network was successfully able to adapt to the risk of FTX as a price data source. So FTX was a data source that was heavily used by many different data providers. The Chainlink network system detected that that was a problem, and then it removed the data providers that were heavily weighted towards FTX, therefore eliminating that risk of that centralized exchange affecting the decentralized data generated for DeFi. And that's why during that crisis, the Chainlink Oracle networks continued to provide accurate prices. So this is a pattern that we've consistently built into Chainlink and know a lot about, and the Chainlink network and community is very familiar with. It's not only how do you make multiple networks to solve a security problem, but how do you then manage the risk of the new problems that appear dynamically as they appear. So CCIP and Chainlink currently is at this fifth level. And if you look at CCIP, you'll actually see that it's made up of multiple networks. So we've even gone further than generating a single network for a service. Every CCIP bridge is made up of multiple networks. It's made up of networks that execute the actual transaction, and then it's made up of a completely separate network called the risk management network that's written in a different stack, in a different way, and it has a completely different goal of validating whether those transactions should happen. So approving or disapproving those transactions without ever signing for them or ever touching the tokens in any way. So you have kind of in CCIP an even further level of decentralization where it isn't even a single network powering every single bridge, which is a segregated, scalable, separate service. But you have one network or a set of networks that are responsible for the transactional throughputs of the network, for actually executing the transactions in the executing DON and the committing DON. And then you have the risk management network, which monitors the transactions for various risks. And you can actually put various other additional risks that you want to monitor in the risk management network. So if you're transferring value, if you're putting in data that's going to trigger and control value, there's a reason that the Chainlink system has processed over $8.5 trillion in transaction value, why it's been live on production for so many years without significant issues. It's because the system not only can make separate services that are secure and decentralized, but it's also because the system can adapt to manage these various risks. And this is the same level of security and risk management that we've now injected into CCIP, and this is why many of the top protocols in public chain DeFi are using it actively and switching to it from other systems that are either made up of basically two nodes, so they're back at level 2, or they're at level 3, where you only have one network which fundamentally can't scale and which aggregates all the risk for all the bridges in one place that's more likely to get attacked and manipulated. So basically, what we're seeing now is that both the security of CCIP and the risk management of CCIP is valuable and useful to both public chain DeFi and private bank chains, which also see the large value in this security. And the organizations we're working with there are very security sensitive because many of them settle amounts of value in the quadrillions. And they have very serious security requirements and review processes. And when they look at the security that we've been able to create through this decentralization, through this ability to segregate bridges into separate services, through risk management as a separate capability in its own separate network, I think what they see is the level of security that is kind of at the very limit of the type of security you could create. And so they're seriously looking and in many cases now becoming willing to put large amounts of value into that system because of that security and decentralization. So the fundamental question for me actually has always been, how much security do we really get from decentralization? And I found that if you can separate out each separate Oracle network, you can scale the security of each Oracle network separately, and then you can add other Oracle networks to bolster that security. For example, we have proof of reserve Oracle networks that can be conditions for the risk management network. And so eventually you can have a multitude of networks managing large amounts of value by doing each of their respective risk management roles and making sure that the transactional value flowing over the system is both properly secured and managed against risk. And this is very important because if our industry is going to grow, we really need to get to the level that the systems in our industry can properly move and secure and prove things, not about billions of dollars, not about hundreds of billions of dollars, but eventually about tens and hundreds of trillions of dollars. And that's what we're building Chainlink to be able to achieve.